Okay, here we go. This is going to be our most complicated tutorial so far. This is preparing projects for the CNC mill, not the robot, but our Easy Router CNC mill. We start in Cinema or your various 3D program. Your end result needs to be an STL. We are going to open a file, whatever STL I can find here. Let's go with let's go with an iPhone. Make a giant iPhone. There it is. It's wonderful. Now, I want to mill this on the Easy Router. I have to create the stock, and my end result in Cinema 4D needs to be the size and the shape of whatever I want my end product from the mill to be. So, I need to create my stock, create object, cube. It's, the dimensions of your stock. So in this case, I'm saying 48 by 6 by 96. But if these numbers are off a little, say 47.75 or 95.5, you need to indicate that here. It's fantastic. There's my stock. I'm going to make it editable. And I need the stock to exist in the positive quadrant in terms of X and Z in Cinema 4D, meaning when I move it, its location is all positive, and then it needs to be in the negative Y. So this corner, indicated here, selecting this point, making that my axis center, that point needs to be at 0, 0, 0 position. I positioned it at 0, 0, 0, so the stock itself is below the work plane, but in the positive quadrant. Now, here's my iPhone. iPhone's really tiny. Let's make a giant iPhone. Giphone. So again, I need my end result from Cinema to be exactly what I want to come off the mill. So I'm going to take my iPhone. Let's actually make my cube X-ray. I'll take my iPhone. I'm going to put it in my stock. Just like that. It sort of floats in the middle. And now I need to cut away the stock so I can see the phone. So I'm going to go to the top view, center my phone better, top view, and draw my boundary here. So I'm going to create a spline. I could do any of them, any of these really, but I'm going to do linear. I'm just going to draw an area around the phone that I want to cut out. This will be the area that gets cut. And then when I get over here, I can just select close spline. There it is. Now that doesn't do anything on its own, so we're going to extrude that spline by dragging the spline into the extrude deformer and making sure that it is extruding in the Y direction. This is X, this is Y, this is Z. It needs to extrude more than 6 inches because it's cutting through the foam. So now select the whole thing, current state to object, connect all those and delete them. And I like to optimize the points, probably not necessary. But now, let's drag that down so you can see it's popping through both sides. Fantastic. And we're going to then bool that shape out of the stock. This cube is called the stock, right? There it is. Look at that. So now, if I sent this to the mill, it wouldn't work. But ideally, this is what I want the end product to look like. I want a piece of stock with foam missing and this weird phone shape in the center. What I'm missing are what I call lattice work. And those are supporting, connecting structures that keep this centerpiece from wiggling while you're milling. I'm going to go ahead and current state to object my bool, just like I did the extrude, and then connect all the objects and delete them. This is what it looks like. It's wonderful. Absolutely wonderful. Before I get to the lattice work, actually, something you might consider doing is making this drop down a gradient to prevent the collet on the bit from hitting the stock. There's a couple ways to do that. One is select this ring of lines and just scaling them in one direction, like this. So then your lines come down at an angle, but obviously that gets weird. It doesn't work necessarily. So another way is to cut your stock with the knife tool, sort of right in the middle. It didn't work, right? Right in the middle. Close enough to the middle anyways. Now I have this extra division. So when I select this ring, and I scale it, it doesn't get so weird. Should have optimized my points. I'm sorry, everybody. It doesn't get so weird. I can scale it however I want. So now it's a gradient at the top, but it's straight down at the bottom, so the collet won't hit this area. I like this a lot. It looks great. This is what I would get at the end. Now, the lattice work. Kind of important, because imagine the mill cut out this shape and then would go to cut other shapes. This would start wiggling around from vibrations, get hit by the bit, maybe go flying, at the very least get damaged. It's important to have connecting structures on the side. Again, for this, I'm going to go to the top view. I'm going to create a cylinder, rotate it so it's facing sideways, and make its radius 0.25, so it's a 1/2 inch. Make this 6 inches. So now I have this little supporting structure that I can just drag and then duplicate wherever I want it to be connected. This is probably way more than necessary in terms of connections, but I've found better safe than sorry in terms of milling. Now the beautiful part about the CNC mill is that you don't have to have a watertight model. Your models get read as a surface. So those connecting structures don't have to be booled together. They can just overlap like that. So this is my end product. This is exactly what I want to come off the mill when all is said and done. It's lovely. It's got all these wonderful things. It's the right size. So I'm going to file, export as an STL, put it somewhere where I won't forget it, desktop, iPhone mill 1, and I want to export in inches. This is very important. When you're exporting for the mill, it's inches. Okay. Then I'm done in Cinema. You should save your project. We're going to go to Microsoft Visual CAD CAM. Could be 2014, could be 2015, doesn't matter. Mine's already all set up. So important thing for you is to tell it what machine you're using and what tools you're using. So before we add anything, before we do anything, I'm going to say what machine I'm using. Under Visual CAM, you want to tell it what machine you're using. You want to use a mill. Turn is a rotary, free mill, I don't know what that is, but you want to use a mill, right? Mill. And then under your machine, 4-axis is fine. If you're going to be rotating your part, if you're going to be flipping it over for a double-sided mill, which we will be doing, you want to set your 4th axis parameters, which is the Rotary Center, so where it imagines the piece is spinning. In this case, this is half the x distance, which remember was 48. This is 24. None of the y distance, because we want it to rotate along the end, and then half the z, remember, which is -6 because it was below the surface. This is -3. Okay. And then we're going to tell it our tools. I already have all the tools loaded, but imagine I didn't. I'm going to load tool library, and wherever your tool library is, all right, wherever your tool library is, should be a .csv file. You want to load that. It might have 18 duplicates, but it would load 18 tools for you. All these. Now we're ready to go. File, import. Mine is on the desktop. I want an STL file. Boom, right there. This is called iPhone mill, the iPhone. There it is. It's beautiful. You'll know it's right if your part is basically the size of this grid, but it starts in the middle. If you can't see this grid, or this grid is enormous compared to your part, then you scaled it wrong, and you need to go back and export as inches, or make sure it's the right size. So now that we've got this file in, we're going to tell it to find the stock. So we can just simply double click on this, or we can click stock, box stock. Copy the model bounding box, that copies the dimensions. And the corner coordinates, we're defining, in this case, the bottom left corner. That's 0, and that's 0, and that's the negative depth, right? It goes down 6 inches. There it is. So, okay. So the stock then exists on top of the part. Now we're going to do a horizontal roughing. Under 3-axis, horizontal roughing. We don't need a region for horizontal roughing. We'll go over that in parallel finishing. The tool, the go-to tool is the 1/2-inch ball mill. Whatever one you need should be there. Feeds and speeds. These numbers are as indicated here. 12,000 is your RPM. Everything is 50, except for your cutting speed is 120. Everything is 50, except your cutting speed is 120. If you have a big job that runs the length of your part, you might turn rapid off. This is transfer speed, travel speed. We're using rapid, but otherwise you could hit set and you can make this 50. But we're going to use rapid for this. The clearance plane is how high the bit goes before it will make a travel move. It's going to be your stock max Z plus 1/4 inch. Cut transfer method is clearance plane. Cut parameters. You don't do anything with this. You don't do anything with this. All you control here is your step over control. Step over for horizontal roughing is literally the step in the X or the Y. So I cut a section, I step over, I cut a section, I step over, I cut a section. For the 1/2-inch ball in the horizontal roughing, we do a distance, tool diameter of 60%. So that's more than a 1/4 inch step over. Cut levels, this is the distance. Cut levels is cut down, so it cuts over, and then when it goes, roughs out a whole area, it goes down. We do 1/2 inch. This doesn't matter. And then your cut levels, this is the highest cut, which is 0, which indicates the top of the part. And the bottom is -6, which indicates the bottom of the part. Now, because we're going to do a double-sided mill, we don't have to go all the way down. So we're actually just going to tell this -3.5. So it goes a little bit below halfway. Engage, retract. You don't have to do anything here. You don't have to do anything under advanced cut parameters. Generate. This will take a minute. Done. Now we can see it open this horizontal roughing here. We can simulate. It disappeared, but that's just simply because we haven't simulated anything yet. Click on the horizontal roughing, hit play. There you go. This is at the highest speed, so you don't see a lot of moves, but if you slow it down, you'd see more moves. All right, not so bad. Now we're going to make a parallel finishing. So we're going to go back to program, and we're going to need a region this time, because if you don't do a region on parallel finishing and you set your top cut as 0 because you want to cut stuff away, it will parallel finish all this extra surface. So we're going to go to the top view, indicated by this button on the left, and we're going to just draw a rectangle. You could do a polyline, a rectangle, whatever you need to do. We're going to click, drag, click, just like that. Now we're going to go into 3-axis again, parallel finishing. We're going to select our region, and click on this, and then right-click anywhere in the blank spot. Drive region number 1, beautiful. Tool, same tool, feeds and speeds. Again, all these same numbers, 12,000 RPM, everything is 50 except your cut speed. Clearance plane, same as before. Cut parameters. You don't need anything here, you don't need anything here. Step over here is actually smaller. 25% is decent, but if you want to go by quickly, make this 30 or 35. Z containment is the same as our top and bottom before, so our highest Z is 0, right? And our lowest Z, we did minus 3.5. Entry and exit, you don't need. Generate. Generation, so that's much faster. It can simulate this. Parallel finish, as you can see, simply goes back and forth, left and right. All right, the simulation is almost finished. Parallel finishing does that, takes a while. And then after this, we're going to flip the table over in the program, not angry table flipping. Simulation's almost done. There it is, it's lovely. Now, under our program again, after parallel finishing, we're going to hit Setup, Rotate Table. The table rotates 180 degrees in our case. Counterclockwise doesn't matter. And you know you did it right when your axis appears over here. So diagonal, caddy corner to your original. That's how you know you did it right. And it should be lined up with the corner just like that. So now we're going to make sure we're here, and we're going to go through the exact same thing again. 3-axis, horizontal roughing, half-inch tool, feeds and speeds are everything. You should know them by now. Clearance plane, cut parameters, cut levels. Step down is 0.5. I'm actually going to make the bottom minus 3 instead. Gauge or check, don't need, generate. Computing toolpath, and now when I simulate this new step, you see it's coming from the bottom. Everything I ever wanted it to be. It's lovely. You can see it cut through, and you're almost home free. If you don't care about the backside, you're done. If you don't need to finish it, rather. But I'm sure most people want to finish it. So we're going to go back to program, and we're going to do 3-axis, parallel finishing. This drive region is the same. Tool, half-inch, feeds and speeds. Clearance plane, stock max plus Z, cut parameters, tool diameter, 30%. Z containment, boom, boom. Minus 3, rather. Entry exit, don't need, generate. Now, we're going to go back to our simulate. Select our 4th section, play. You don't have to suffer through this. Okay, our last simulation is coming to an end. And when all is said and done, what is on screen is what we want our final product to look like. Here we go. This is our simulation. I want it to look like this weird roughed area outside the model with my support structure, and then this lovely weird iPhone shape in the middle. Boom, ready. So now, you gotta go folder by folder here, right click, post. You're posting tap files to wherever your destination is. It's best to have some naming convention that says horizontal roughing, in some naming convention that says parallel finishing, so you know the difference. If you find that you can't see the tap file when you post, it's in your post settings right here, post settings, posted file extension .tap. That's what you want, not all these other garbage. And that's it. Then you take the tap file, which you'll see post, and then name it tap file. This file, this is the G code, straight up G code. Save that to a flash drive, take it down to the mill, and run it through EasyRouter's Mach 3 program. Okay, here we are going to actually run our file on the mill. I've been told that this computer down by the CNC might actually get updated or replaced in the near future, so if this video is outdated, I apologize. First of all, the password is the same as the login, which is milladmin, all lowercase. This computer has to use Windows XP to run EasyRouter, which is the software for the CNC machine. So we're going to go ahead and open up Mach 3, which is EasyRouter software. It's right here in the middle. And there's only one profile, it's the router. Well, this interface looks a little daunting. It's actually quite simple. First of all, make sure to reset or clear any warnings that are popping up. If it says external e-stop requested like it does here, that's because the machine was turned off from hitting a limit switch. So we're going to go ahead and move the machine and turn it on. So if you have any flashing warnings, you can hit reset or clear to make them go away. Our file is on my flash drive. Stand by. So move your tap file to the desktop so you can see it. You're going to load your file using the load G-code button. But first, we're going to prepare the machine to run. In advance of milling, you want to warm up the bit, which just literally means you want to hit spindle. To turn the spindle on, you can hear it running, and slowly bring up the speed to about 10,000. Using this up button. So it'll be warming up while we do the rest of this. We need to do a few things. We need to reference all home, we need to find our zeros, and then we need to load the G-code. So first of all, you need to reference all home. The home is the closest corner to you of the bed, and then it moves up to the highest Z. So we're just going to hit reference all home. And this finds true zeros of the CNC machine. It moves relatively slow when doing this, so you might find best practice is to move it yourself close to this position before hitting that. Once it has hit the limit switches and Z, X, and Y, it will go to true zero. Now what you do is you find the actual zero position of the corner of your stock. In this case, I'm using a scrap piece which has not been secured to the bed, so I'll have to be super careful. But what you need to do is bring the bit down using the page down button. If you hold shift and hit page down, it moves faster, just like if you hold shift when using any of the arrow keys, it moves faster in X and Y. Bring the bit down so I can use it as a reference To 0 my X, I want to line the bottom of the bit, so the center of the bit, along the long side of the piece. You're going to just do this by looking. Get it into position. You're going to write down this number. It's a positive number in this case, sometimes it's negative. Next to 0x, you're going to write this number down. Then you're going to hit 0x. You do the same thing for y by moving it backwards and forwards until the center of the bit is lined up with the short sideways edge facing you. So we're going to get into position. We're going to write down this number. It's negative in this case. And then we're going to hit 0y. For z, I found that it's best to move the spindle over the stock so you can hear it making contact with the surface. To 0 the z, you want to make sure the bit is just barely in contact with the top of your stock. In this case, I'm bringing it down slowly until I can barely hear it make contact with it. I could write down this number, but you have to find the 0 again no matter what you do. So we write this number down, hit 0z. Right. If you want to move the bit to any particular position, you can type in the prompt here, X and the number you want. I'm going to do 0, Y the number you want. F is the speed at which it's going to move. So this is 100 inches per minute. I'm going to go to XY, 0Y at a speed of 100. If I want to do X20, F20, speed 120. Oops, that's X20, Y20 at a speed of 120. Type just that out. It'll go exactly where I want it to go. You can hit escape or anything else in the middle of that and it'll stop. So now that I found my zeros, I've been warming the bit up this whole time. I want to load my G-code. I'm going to load my G-code. It's on the desktop and it's called iPhone Mill blah 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 blah. I'm just going to hit open. Let's see, the G-code appears on the left, literal G-code, and on the center is a display of your job. You want to hit Regen toolpath before doing anything else. Regen toolpath, basically refresh. Regen toolpath. Now, if your stock is secured, you found your zeros, you've loaded your G-code, you're ready to go. You want to bring the spindle back down. So slowly bring the spindle back down to 5,000 RPMs, which is the default, using this arrow on the left. And then you want to hit spindle to turn spindle off. And then whenever you're ready, you're just going to hit cycle start. And it's going to go. At this point, you should leave your mouse hovering over feed hold. That's basically your pause button. If I hit feed hold, boom, it pauses the entire job. And then I would hit cycle start, as you see down at the bottom, to resume. Should you need to stop, stop works, obviously, or there's an emergency stop button located on the green control box for the mill. Stop. As you can hear, stop's turned off everything. In the event that you need to restart a job in the middle, for example, you're going to use what's called run from line, which is right here. You would go to a certain location in the job, whatever line you finished at, which is displayed here. So you wanted to be at line 3000. Let's try to get to line 3000. And I want to hit run from line. It'll run through the G-code up to that point, and then tell you, press cycle start to preparation move, check spindle. That means make sure the spindle's off. So hit cycle start. It'll bring up this prompt, which illustrates the preparation move it's going to make and tells you, I'm going to start the spindle. So a little check mark there. You hit OK. It starts the spindle. It moves to that location. And it'll run the job as if starting from line 3000.